Naniva has developed a breakthrough software solution for the automated detection of potential failure modes in products and processes. TechScan enables the recognition of potential failures caused by numerous and diverse factors, such as mechanical fatigue, thermal and electrical stresses, erosion and corrosion, variations in production, typical wear and tear, and many others. TechScan is a universal solution. It is adaptable to the task of automating failure diagnosis in virtually any product, from a child's toy to an aircraft carrier. TechScan is based on the original method for modeling cause-effect chains in complex technological systems. TechScan's knowledge base contains models of hundreds of typical components. These are bolts, nuts, springs, shafts, bearings, seals, valves, motors, wires, switches, and countless other components. The model of a typical component takes into account the streams of energy and materials that flow through this component, as well as the materials the component is made of. These component models, similar to Lego pieces, allow for the construction of the prevailing majority of modern products and technologies. To understand how TechScan works, consider a somewhat simplified analysis of a generic automotive side view mirror. The side view mirror is a multi-component system comprised of mechanical, electromechanical, optical, and electronic parts and assemblies. TechScan analysis of the mirror begins with building its structural model. Next, a functional model is built. Various other components and factors are taken into account: adjacent parts, numerous environmental factors such as wind, moisture, vibration, heat and cold, the driver's hands, etc. The functional model is ready. We can now run the failure mode simulation. Suppose we want to find out under what conditions the mirror lens will not move. We assign the failure mode absent to the function mirror turn and click the simulation icon. Several seconds later, the screen changes. It now shows numerous cause-effect chains that may lead to this major failure. A detailed description of all the detected failure causes, and there are dozens of them, is found in a report generated upon the user's request. TechScan is capable of analyzing really complex systems comprised of dozens and even hundreds of parts. To this end, multi-component systems are represented as single assemblies. This approach allows for finding out how a change in one part of a complex system might affect other remote parts. The model you're observing on the screen includes the side view mirror, the ignition system, the fuel pump, and the engine. What might happen when you insert the key into the ignition switch, turn the switch on, and decide to adjust the position of the mirror? The pivot motion of the mirror will cause the DC motor to rotate, thus converting it into a DC generator. The voltage from this generator will flow, via the external circuitry, to the ignition system, and from there to both the fuel pump and the engine. This may result in a spontaneous start of the engine. An unlikely scenario? Well, several years ago, this exact failure mode forced one automaker to spend millions on warranty relief. Notice the speed and comprehensiveness of the TechScan-based analysis. Now then, let us sum up. TechScan's benefits are extraordinarily high speed of analysis, unattainable via conventional or manual FMEA. High reliability of failure detection. Universality. The ability to rapidly analyze complex systems. Applicability to the early stages of the product development process. Unlimited model reuse and editing.